functions and onto functions. Please see it very carefully, right? Before starting this one-to-one functions and onto functions, we have to see what are functions. So functions are basically a relation. It's a relation between the input and the output. Let's say suppose I'm saying x is equals y is equals to x plus 2. Every time whatever I'm putting as in x as an input, suppose let's say I'm putting x as 1, y is equals to 3. If I am putting x is equals to minus 1, y is 1. If I am putting x is equals to 0, y is equals to 2. I am putting x is equals to negative 2, y is equals to 0. So every time whatever I am putting a input, I am getting a output, a different output, right? So this is the one-to-one function because 1 is connected with 3. Okay, then negative 1 gives me 1, 0 gives me 2, negative 2 gives me 0. So every single input gives me a very different output, right? So please remember one thing, for one-to-one function, if we are talking about two sets, set A and set B, so we have to focus on set A, that every single input gives me a single output. That we have to see, means every pre-image, we are talking whatever the elements that we have here, these are called as the pre-images, right? We called it as the pre-image, and this we called as the images. So every pre-image is connected with a different image. So that is called as the one-to-one function. Now let's see what is the definition here. The definition is very simple. What it said, if a function has no two ordered pair with different first coordinates and the same second coordinate, right? Two inputs, two inputs that we have. Again, see the ordered pair, no two ordered pair with different first coordinate. Let's say minus 1 and 2 and 1 and 2. They are saying with different first coordinate and the same second coordinate. Two inputs, two different inputs can't give me a same output, right? Let's say suppose we have a function y is equals to x square. I know that if I'm putting x is equals to minus 1, I am getting y as 1. If I'm putting x as 1, again I'm getting 1 only. So two different inputs give me a same output. This is a function, but it is not a one-to-one function. So one-to-one means every single input has a different output. That is called as the one-to-one function, right? So that we have to see. For example, let's say suppose we have this thing. So kindly watch it here. So if we will see the first one, R is connected with 3, B connected with 7, M1, N4, N9. 4 is alone in the set B, but we have to watch out for the set A. For one-to-one function, we just have to see the first coordinate, that a single input gives me a single output. Obviously, when you are putting something as an input, a different input, you will get a single output only. A single input can't give so many outputs. It gives me a single output only. So we just have to watch out for the A set, basically, that it should give me a single output and no two inputs give me a single output, right? Now, this is not a one-to-one function because we know that two inputs, two different inputs give me a single output. So this is not one-to-one function. One-to-one means single input, single output, single input, single output, and it should be fixed. Okay. Now, let's talk about, suppose we have Q here. Let's say, suppose we have Q here. So Q is alone here. It is not fixed by some number. Q is not fixed by some number. So this is not one-to-one, right? So one-to-one, every single input should have a single output, right? So that's that. Now let's talk about the one-to-one onto thing. What is onto? For onto, like for one-to-one, we are watching out for the set A. For onto, we are watching out for the set B. That every single element in set B should connect to uh, some elements in set A. Okay, so for onto, we always watch the second set. Now, if you will see here that onto functions is that every element in the core domain. Core domain means the set B always. Core domain means set B. So we are always watching out this. Every element here should be fixed. None of the elements should be alone in set B. There exists an element domain which maps to it. Again, this sounds confusing. So don't get confused. Just see it here. I will show you here. Kindly see this one. This is an onto one because every element in set B is connected with something. 2 connected with this. 5 is connected with M and 5 is connected with N. So this is not 1 to 1, but this is on 2. This is not on 2 because 7 is alone and 3 is alone. Please remember one thing. For 1 to 1, we have to see the set A, that every single input should connect with some output, a different output. And for onto, we always watch the set B, that none of the element in set B, that is in the codomain, should be alone. It should be fixed, right? It should be fixed. So if I will say I'm taking an example, so example is very, very important here. So what is the example here that I want to give it to you? Let's say suppose this is 1, 2, 3, and this is A, B, C, D. So let's say I'm talking about A with 1, A with B, 2 with B, 3 with C, and so on. So this is not onto, first of all. Why it is not onto? Because for onto, we have to see the set B always, right? And set B, D is alone. D is not fixed with some input. So it is not onto. Is it 1 to 1? It is not 1 to 1 because 1 is connected with A and B, and a single input should have a single output. And also, it is not 1 to 1 because 1 and 2 they are connected with a single element. So, single input, single output we want, right? Single input, single output we want. So, this is not 1 1 also, right? So, that's 1 1 and onto. It's very simple. Now, let's have a talk about some questions here only. So, I'll show you just a second. The questions are, this is the first question. Okay, now what you have to see, it's very important that the function that is equals to 5x minus 2, and function means f of x means y only. Whenever I am putting as x something as x, I know that I will get a different output, because if I am putting x as 1, my y is 3. If I am putting x as 0, my y is minus 2. If I am putting x as negative 1, my y is minus 7, right? Right? Clear? Now, please see one thing. Condition you have to see before starting the question. They are saying R to R means first set also having R real numbers and second set also having real numbers. Means in negative, positive, zero, fraction, decimal, all the values you have in this. So whatever I'm putting, I'm putting the integers only. If I'm putting a fraction value, then also I will get a fraction value. If I'm putting a decimal value, I will get an answer in decimals also. So it means every input give me a different output. So obviously it is 1 to 1 because every single value of x give me a different output. So it is a 1 to 1 function, right? It is a 1 to 1 function and every element is fixed. So yes, it is a 1 to 1 function, right? Now let's move towards the next question. The next question is this one, that they are saying, wait a minute, they are saying, first of all, that's R to R, means every element is there, negative, positive, fraction, and all that. Now the question is this one, is it onto? For onto, we have to see the set B. For onto, we have to see the set B. And in set B, every element is fixed. We know that because whatever I'm putting as an x, positive, negative, zero, fraction, decimal, I will get something as a value here also. And every output is fixed. Let's say suppose the values are like minus 1, minus 2, because they are saying also the second set is also R. That is a real number. So you have the integers, you have the decimal values also in between, the fractions also you have in between. So all are the fixed, because as you are putting something as a real number, obviously you will get something as a real number only in this particular function. So yes, we can say it is an onto function because every element of B is fixed with some input, right? So yes, it is for sure. Okay. So it is onto. Now let's talk about this one. Obviously, it is one to one function. It is one to one function because here one thing I will tell you, this is set A and this is set B. Set A also having integers like say minus 1, minus 2, 0, 1, 2, 3, and 4, so on. And set B also having minus 1, minus 2, 0, 1, 2, 3, and so on. Here, I have to put the integers only because they are saying Z. Z means integer, like negative, positive, zero, simple numbers we have to put. We can't take fraction, decimals in both the sets because they are saying Z to Z, right? So whatever I'm putting, I am getting an integer only because I am putting the integer only. So every element is fixed. So yes, it is 1 to 1. But let's say, suppose they change the question now. R to Z. R to Z. So here, between the single numbers also you have the fractions also and decimal also, because the input is the real number. But as you are putting something as a half, let's say suppose you are putting half in the place of x, you are getting 0.5. But in set b you are only having the integer, you don't have the decimal value. So this is not one to one function, because some inputs do not have the output. So this is not one to one. But here they are saying z to z, so it is one to one. As simple as that, right? So yeah, that's that. Okay. So I think the one to one and on to is clear.